Good afternoon.
Hi, Deepa. How are you doing?
I'm good. How are you?
All right. So, I dropped your exam off with Dr. Gonzalez.
Mm-hmm.
I scanned it. Everybody did well. You did really well. I graded it using Gemini AI,
Mm-hmm.
but it doesn't grade everything. So you gotta wait for we gotta wait for the for her to do it manually. You know what I mean?
Mm-hmm. And did she give you the answer key for the exam one?
Um, no, I don't have an answer key.
Okay.
I don't have an answer key. But I mean, you did well.
Okay.
I, like the answer key I have, it's
Mm-hmm.
not um, it's not going to be accurate.
Okay. And also, I want to say today, I think after 2 o'clock, I won't be able to talk or like I have to leave because I have a doctor appointment
Sure,
today.
no problem.
Okay. So our
Um,
exam is on 6th.
yeah, I don't know when the exam is. I don't know when the
Okay.
exam is. Um, just briefly, I mean, this answer key is not it's not accurate.
Okay.
Okay, so but I'll give you an idea of what it might what it might look like.
Okay.
All right, so hold on. So if you can you see the screen?
Yes.
Okay, so hold on. Hold on. You can make an appointment to see Dr. Gonzalez physically. I think she'll be here. She's here on Tuesdays at 11 o'clock.
Sunday?
So no, on Tuesdays.
Okay.
Yes, office hours on Tuesdays at 11 o'clock. So this person hypothetically got a really good mark, 89 or something like that, and
Mm-hmm.
move back. Has a mind of its own. So okay, so hypothetically, this is a person that took the exam. The exam has 200 points, but is graded at 175. Like that's her grading. Like
Mm-hmm.
she's setting her ways. I don't know like exactly how she does things, but on this exam, this is what the AI gives me back.
Okay.
Oh, I'm sorry, this is exam one. Hold on. This is wrong exam. Hold on.
We might get question from exam 1 for like exam 3, like our final. Some question.
And that you have to ask her too. That I don't know either. She hasn't I don't know how she she might do that. I would more often than not just focus on what I'm going to do on Wednesday, which is 9, 10, 11, and 12. And then,
Review.
yeah, I'm going to
Okay.
start to review Wednesday. So log in,
Mm-hmm.
um, log in on hey Hernandez, log in on Wednesday and I'll know more. Or if you email her, you can email her and ask her because she hasn't responded to any of my emails recently. You could just ask her if the final is cumulative. All right. I put a
Okay.
sample if you didn't get the grade you like or you're not doing well, I put a
Mm-hmm.
sample of a recommendation I could write for you. Like if you take the final and get, say take the final and you get a B plus and you're not happy.
Mm-hmm.
I can write you a letter of recommendation, to take the next class, to say you came every day, participated. So I put a sample recommendation in the course. Everybody did well. No one is failing. It's just that you might not get the grade that you had wanted. That's what I saw. So what I did was I'm gonna review some sample exams from MIT, and out of the 12 people that were there, 5 people got perfect grades. So I'm not saying you're one of them, but that's based on my Gemini AI. You have to ask her how she graded, but based on how I graded it with Gemini AI, the Gemini AI and ChatGPT, they don't grade resonance structures. Like they don't do the OCR, optical recognition, very well. So when they grade it, you might get a higher mark using the Gemini AI. But everybody did well. 5 people got the exam perfectly correct. The other 7, if you didn't do as well as you had wanted to, you could see whether she counts the highest grade, more. I could write you a letter of recommendation, and you also have more time. So the fact that we finished a little early, that I don't know when the final is, Michael, if you're there, if Michael is there or Hernandez is there, Michael, you can email Dr. G and see if the final is cumulative. I don't know if it's cumulative or not, and I don't know when it is. Some people got the same grade as exam 1. Some people improved. So yeah, yes, Hernandez. I'm not sure. Usually, the registrar has that info. So I could look right now. Just check. Final exam schedule for organic. But you can email her. You can email this person. You can email the coordinator, and she'll respond. Wherever she is right now, she hasn't responded. I'm looking at the academic calendar. Oh, you know what? There's practice materials and study doc. Okay, hold on. I just found something that could help. You. Okay, hold on. Normally that information might be in the registrar. So I could, as soon as I get off the line today, I could tell you. I can tell you that, but I'm checking now. Normally, you go to the registrar's office. It doesn't, but it might not have a specific date. Download academic calendar. All right, I have the academic calendar. This is for fall September. The last day of Saturday classes is August 2nd. Okay, so the last day of Saturday class, but it's not a Saturday class. Okay. The last day they withdraw was the 22nd. Final examinations begin August 4th. So August 4th to August 10th. So you have a lot of time to study. You have a lot of time to study for the final. So what I did was, there are two things you have to do. Two things we have to do. We have to find out whether the final is cumulative and when exactly it is. So if the finals are between the 4th and the 10th, let's find a Saturday between the 4th and the 10th. So I would assume August. It can't be August 2nd, so it could be August 9th. There are two Saturdays, August 2nd and August 9th. So I would imagine August 9th. So if it's August 9th and today is the 28th, you have I'm going to finish chapter 12 today. And then after that, you have about 2 weeks to study for this exam, which is a long time. That's about the normal time. So let me just go over it just briefly. Again, Gemini, no one failed, but if you don't get the grade that you didn't want, your grade is going to be combined with the lab grade. So what happens, and Dr. Gonzalez is going to issue the grade. That's why I said try to make a point in, as a rule of thumb, Deepa, Jesse, what you should all do, Michael, Shayna, what you should all do is make an appointment to see her. Make sure that it shows that you're concerned with your grade, that you want to know how you're doing, So that way when she delivers the grade, she remembers seeing you. So this is what Gemini AI kicks back. All right. So I'll just show you briefly what it kicks back. All right. So it's going to kick back. The first question was enantiomers. The second question was achiral, and the last one was chiral. Okay. This is what the AI kicks back for a typical student. All right. I'm not going to say who. Okay. This is what the typical student got. 5 people got the exam perfectly correct. The other 7, just didn't get the exam perfectly correct. That's all I'll say. Drawing, the AI doesn't grade well. So if you drew ethanol correct, the person got 4 points. If you drew 2-hexanol, if the drawing was incomplete, the AI doesn't grade it. If you drew 2-methylpentanol, the person did well on that. Naming, you had to name the molecules after that. Then when you get to page 3, it asks you to secondary hydride. Where is that? 5. The difficulty came about when The difficulty came about with the SN, this question. When the SN2, when you had to define what was SN2 and SN1, but we did an activity on it. The problem is, this has a mind of its own. It's just skipping. It did that on its own. This is where the difficulty came. This question, when the rate of when you had to look at whether the solvent played a role, that's where whether the solvent was polar protic. If it's polar protic, it's SN1. That's where people lost points. That was the only problem that was there. So, but otherwise, no one failed, and there were 5 people with perfect grades. So what I would do at this point, if I was in your shoes, is I would, she's here, Dr. Gonzalez is here at 11 a.m. on Tuesdays. So you just come to the main office is natural science. LaGuardia. There's 2 secretaries there, and the office is M-204. Or you could email natulsci@lagcc.cuny.edu, or you could call 718-482-5940. Say, hey, I'm with Dr. Craig. I'm with Dr. Gonzalez's class. I just want to find out whether the exam is cumulative or whether it's just based on the last final. So what I just saw, hold on. Oh, I got it. Hold on. It's an error happening. Emergencies happening. Hold on. All right. Sorry about that. Okay, I want to show you something. While I was just Googling, I found this. So this is in StudyDoc, Deepa. Take a look. Michael, can you see what I just found? Hello? This is a website in StudyDoc that has some materials. So this is something in StudyDoc you can maybe take a look at. Michael, can you see this? So this looks like some of the labs that you might have done, correct? Okay, Shayna, so here's what I want you to do. A lot of times with StudyDoc and Course Hero, you have to upload 10 documents, and then you get these free. Or if you're smart, right, you don't have to upload anything. What you could do, if you just click on, let's say, this is trending. These are what's trending, right? So if this is one of your labs, right, you click it, right? And if it doesn't, it might not let you see the whole thing, or it might give you a free trial. You could upload documents to share, right? And when you do it, you got to upload these documents, and then you get some unlocks. All right. If you don't want to do that, if you're fast, you could just take a screenshot of what's there. So you go to this course. There's 105 documents associated with these courses. Here's notes, pages, right? Chapters. Here, here's the extraction lab. So here's what you could do. If you take a screenshot of this, you don't have to download anything. You know what I mean? Here's the whole lab, or most of it. Okay. So that might help. You can see it's all with LaGuardia, right? You can see who uploaded it to. She uploaded it. You can follow her, you know. So here are some study materials for the class. Okay, I also found this. If you want to know where the class is going, all right. Okay, here's a sample. Wait, before I do that, I'll show you this. Here's a sample recommendation. Oh God, it didn't download like I wanted it to. Save as downloads. Yes. So if you go here, you see where it says sample letter of recommendation. This file here. It's not letting. You can just take a look at it. It's not letting me show it. You can just take a look at a letter of recommendation I've written for someone else. I'll try to add the file. It doesn't let me add such a file, but you can take a look at it, and you can see a type of letter I could write for you. And what I did want to show you is this. Here are exams that are more complicated than the ones you are receiving now. So this is a lab not from your class. Okay, it's from the site I like. It's from MIT. Just so you have an idea of where this is going. This is your exam 2, and this is the information this is, again, it's MIT. It's not your class, but this is some of the things that you would have been asked. Some naming, right? Circle, chiral, achiral. So it's the same type of exam. Same thing that you did on Saturday. Circle any meso compounds. This exam is in the portal as well. Label enantiomers, diastereomers are the same molecule. So I want you to go through this, and I have the answer key. Drawing Newman projections. You should have known that for the exam. You should have known the alkene reactions. These are alkene reactions, SN1, SN2, E1, E2 reactions. At MIT, you have to name it. They don't give you the molecule. You have to draw the molecule and then do the chair conformations. You should have known chair conformations. You should have known anything that had to do peroxide, free radical, how to read a table. So this is exam 2 from MIT. All right. So your exam pretty much looked exactly like it. You can go into the content folder, and I'll take you into the content folder deeper, and I'm going to show you is exam 2. I'm going to show you exam 3. So this is pretty much what the information I'm going to cover today and what's going to be on your final. I'm going to read it into the recording. So deeper, when you leave, you have the recording, you just come back to it and just see what's there. All right. So these are the type of problems that you should be able to master. Example, a pKa problem. What's the major product of a reaction? Describe this molecule. And you have this in the content area. Reaction coordinate, potential energy diagram. A lot of you asked me what's on the left. Potential energy is on the left. Reaction coordinates on the bottom. Label, pairs, enantiomers, diacetyl. So that comes back at you again. Here are some long questions. SN1, SN2 conditions. Okay, this is what I'm a little concerned about. And what I did was I put there was free retrosynthetic software that I'm trying to get an app up for you that it was free, so to teach you this. All right. So at MIT they ask you to design synthesis. Whether Dr. Gonzalez might ask you that, it is something that comes up in chapter 12, which I'm going to cover today. So this is why I wanted to show you this, because you need to know the reactions well enough that you're able to provide a stepwise mechanism for the following transformations. So at MIT, they ask you to know mechanisms. So I'm going to show you what the answers would be. Okay, this is not MIT, but I don't know, but your book does ask you to cover this information. Let's stop sharing. I'm going to share application screen. I'm going to go to content. I'm going to share. So here's practice exam from MIT. Here's the sample solutions. So you maybe want to use this as a guide. Deepa, Shana. So estimate the pKa of the proton indicated. So you're going to look at acetylene and know that the pKa is 25. That's a popular question. Estimate the pKa of the proton indicated. You're going to look at the proton and phenol and know that the pKa is 10. This you have to know from reading. All right. Identify the major product of a reaction. So if you have BR2, you know it's not in the dark. It's going to be not free radical. You're going to know that it's that has to happen at the BR. We spoke about this in the review before class. That the BRs are large. BRs have 79 AMU. So they're going to add trans. The atom is not. They're 5 times bigger than carbon. They're bulky. They want to stay out the way. What's the major product of this reaction? Here's that butyl oxide, strong base. Don't even think about it more often than that. It's E2. It's an elimination reaction. A bulky, strong base is E2. How would you label this monster? As an E alkene. Know how to do that. This is a typical exam questions, and they're really good, and they're not. Here you have the answer key. So Dr. Gonzalez covered these same things. Here's an example where you have to know R and S and R. So everybody pretty much got this right on the last exam. You didn't have problems with this. Okay, this is something that might come into play whether something is SN1 and if it's SN1, of course it's some a substitution, and it could be rearrangement. This SN1, it's a pentavalent transition state. That happens with primary. So maybe you know how to look at these. This question, if it comes up, this is how well, and this is what we're going to be doing for today, and I'm going to do this tomorrow. Let's take a look at this question. Design a synthesis of compounds 1 and 2, 10 points each. Bear in mind, I'm going to give her the homework problems. So she's going to base the exam on the homework problems. She's not going to base the exam on what I'm showing you right now. But some of the homework problems are synthesis problems, which I'll try to get to today. Chapter 12 is actually 2 or 3 chapters in the norm. Chapter 12 is a huge chapter. It's going to take me the whole 3 hours to do it. I'll try to get through the whole chapter today, so we start reviewing. This is an example. I wanted to start the lecture out fast with what a retrosynthesis is. So for problem number 1, you have to try to split the molecule apart. And when you split the molecule apart, you say, well, how would I synthesize this molecule? All right, so I'm downloading some software now that will help us, and you probably could take an image of this, and if you take an image of this and upload it in Gemini AI, it might give you some information. I can do that right now for you if you want. The synthesis of problem 1 is written below, where you use a strong base, and you start out with ethylene bromide, then you add a triple bond, and once you add the triple bond, then you add the phenol ring, and once you add the phenol ring, you add another triple bond, and then you convert the triple bond to a double bond. Okay? Deeper, that's what you would have to do. For problem number 2, the retrosynthesis is down below. Is this one, where you would start with the starting material you would start with is acetylene and the pentyl bromide, and then you would add you would now add acetic acid. This is not acidic, it's acetic acid. It's it's a propane with a carboxylic with a aldehyde group on carbon 2. Then once you added it, it converted to an alcohol. Okay. There is quite a possibility that if you took if I take a screenshot like this of the molecule, now I have a screenshot of it, and I go to Gemini AI, and I kindly ask Gemini AI, you can see what I'm doing deeper. I'm going to ask Gemini AI to develop a retrosynthesis. Please develop Let's see what it does. While we're waiting, there's some other chemistry. There's a chemistry chat GBT just devoted to chemistry. So it does. It doesn't give you the pictures of it though. Oh, it does. Okay. Epoxidation. All right, so it does give you some information, but I'm downloading some. Again, I'll show you the link for it. Okay, share. Stop sharing this. I'm going to go to Share application, content. It's not here. Hold on. Um, okay, so if you guys can take a look at this, I'll put the link. A lot of times, this is one. Um, this is one retrosynthetic app that might be free. So if you want, I can put this link inside the content area. I ordered the trial, so hopefully they will give me they'll give me access to it. There are other platforms for retrosynthetic software, but they were free a few years ago, but now they're not. I don't know why, but for whatever reason. But this is the website to one of them. That if I'm permitted to use it, I'll show you. It's an app that carries out retrosynthetic software, retrosynthetic reactions for you. But by the time we finish chapter 12, we'll have a better idea. Okay, so just to finish up, I'll just do one more. Here's a sample final from MIT. All right, again, the MIT website, people get scared of MIT. It's nice that it has the exams, and it has the exams, and it has the answer key. So these are typical questions. First, these are synthesis problems. I don't know if you had Grignard reagent, but we didn't discuss Grignard reagent in lecture, so you probably won't have it in lab. These are typical synthesis problems of what we're going to discuss now. And because we talked about chapter 9, the triple bond, these type of problems might come up. So this type of exam when I review, I'm going to use this. It might be a good idea to start to look at it now. Here's something we're going to talk about today. Because I know you don't have any sample exams to review from. Also with MIT, what's nice about it is that you have the answer key. So Michael, Shayna, Deepa, this is what your final exam might look like. As you can see, Dr. Gonzalez doesn't really lean on mechanisms. However, she might, by the time we get to what we're going to get to today, here's a good question that could appear on your final. For the following pairs of reactants, identify electrophilic and neutrophilic components and the identity of the product. Note the actual nucleophile and electrophile may be an intermediate that is formed after reaction with the reagents shown in step 1 of each transformation. So these are some questions that might appear. This is a good question that might appear. Write a complete stepwise mechanism for the following reactions. This would be a good question at MIT. This question comes up a lot. And this would be a typical final. So I like to go over because we have the answers. This is something from chapter 9, where you would have to know what would happen if you added 1, 2, and 3. If you added the strong sodium amide, then that cyclic ether, and then water at pH 7, what would happen? Here are synthesis problems, which are, to be honest, are kind of you don't really see these problems till Chem Organic 2, but we're covering the information for it now. So I'd like to go through these problems. Okay, so with no further ado, let me get to chapter 12, and I prepared a big Josh Osborne lesson for you. All right, it took me a few days to do this, so I hope you appreciate it. All right. Can you guys see the screen? Michael? Simran? So this PowerPoint is in, I'll confirm that it's uploaded inside of your content folder. This is chapter 12. This is the Josh Osborne videos. Josh Osborne has, as you can see, over 32 videos on chapter 12. So it's a huge chapter. It has a lot of information. I'm going to do the best I can, and then we're going to start to, this is going to take me about till at least 4 o'clock, and then what we'll do is we have a nice recording, then we'll move on. You can always look at the recording. If you're leaving early, deep up, look at the recording. So Jennifer, Jesse, here we go. All right. This is chapter 12. Okay, so we're going to go in order. We're going to go halogenation of benzene. We're going to go nitration of benzene, sulfonation of benzene, Friedel-Crafts acylation. Friedel-Crafts acylation, that's the most important part if we get to the synthesis questions. All right, and we're taking it home. If you made it this far, you guys all did well. Again, 5 people got the exam absolutely correct. There were 7 grades like below, absolutely, B's and C's. So let's try to do this. You have about 2 weeks, all right? And hopefully the exam is on the 9th, okay? So let's go. Okay, so the first video is what I did was to make it easy is I took the last slide of each of the Josh Osborne videos and I'll describe them to you. So the first thing you have to know is EAS, electrophilic aromatic substitution, where you just have a nucleophile, and the nucleophile replaces either a hydrogen or a halide on the ring, right? Okay. Okay. So in case you have to describe a mechanism, or in case you can see what the mechanism is, you have this chloride or halogen and iron trichloride, and you make this active electrophile, this thing with like 5 chlorines on it, okay? And then you have this chain with a double bond. Add a halogen directly on the ring. All right, the same thing goes for nitration. We actually do this lab at the College of Staten Island. I don't know if you did it here, but you generate something called the nitronium ion. I had a good student, a friend, Detran. That ion is very dangerous because you're going to be when you do this lab, you work with two very two strong acids. Detran was actually hospitalized for 2 or 3 days. He had a lab accident doing this lab. This lab is kind of dangerous. It is done. It is still done. And this is the mechanism for it, for sulfonation. Okay, so now something similar is a sulfonation, where we're going to put SO3 on the ring. Okay, this is Friedel-Crafts alkylation. So this one is very important, as you see in the synthesis reactions. And what's deceiving about organic chemistry, Shayna, is that you have to know these reactions backward and forward. So you say, okay, my job is done. I know Friedel-Crafts acylation, and I know how to take a hydrogen off, use this species that has 4 chlorines on it, extract a hydrogen, form a carbocation intermediate, watch for any rearrangement, and add a tert butyl group on a ring. Okay. Bear in mind, what if I had to go backward? What would you do? What if I gave you the tert butyl of the benzene ring with the tert butyl group on it? What would you do? Okay, so here's some features of the Friedel-Crafts acylation. No, what you expect, you did not get. Why? Because there's a carbocation rearrangement, and you're going to form the more branched tertiary product. Because carbocations like things that are tertiary, they like to be supported. Okay, so there's no reaction if an amino group or strong electron withdrawing group. So we're going to talk about the difference between electron withdrawing groups and electron donating groups shortly. Okay. This is Friedel-Crafts acylation. Okay. So now you see that deeper. You see that R carbonyl group? It's called an acyl group. And if it has a chlorine on it, it's called an acyl chloride group. Now I'm going to attach it to a ring using the Friedel-Crafts reagent. So it's using a Friedel-Crafts acylation. Okay. Chemical modification of benzene substitutes. Okay. Okay, these are very popular reductions. Again, Shayna, look at the reaction going forward, and organic chemistry is a very deceiving type of course. You have to look at the reaction going backward, meaning, so eventually on your exam, which we'll go through, we have lots of time. Today's the 28th, so hopefully we have 2 weeks to learn this. So let's look at the reduction. See that carbonyl bond, Shayna? I'm going to flatten it. I could do it 2 ways. I could use a Clementon reduction, or I could do a Wolff-Kirschner reduction. Okay. While I'm on this, what I also did is I made a list of convenient websites. These are the Brad Pitt, Jay-Z, Beyonce, movie star reactions. So what I did was, when I saw that, anything that struck me like that, I made a list of convenient websites. Hold on a second, guys. The main office is contacting me. Sorry, guys. Let me go to the site I had, Friedel. Well, this is a video of it. So I think so. In your content area, you have a list of videos. So when something stood out for me, like the Wolff-Kishner reductions, I made a list of important videos that you can watch. So I'll make sure that you have that list. This is one of them. You probably won't be asked the mechanisms because she's not a mechanism type person. Okay, let me get back to the Google Slides. Sorry about that. Okay, so you can watch that video. I'll make the list of videos that are important. So benzylic bromination. Okay, also watch of course the Josh Osborne videos. Okay, so this is something that might come about. Again, remember, guys, we're going forward and backward. Michael, forward and backward. Shayna, forward and backward. Deepa, forward and backward. You need to know this reaction forward and backward. So if you see MBS HV. You're going to make one of your index cards, Michael, like you had, and you're going to have 2 weeks to memorize this for the final. You're going to know that you're going to put BR, and it looks like the BR went secondary. The BR went secondary, okay? The next one is side chain oxidation. All right, this is important. Note, whenever I put permanganate or anything with a lot of oxygens, dichromate, you did this lab in Chem 2. All you have to do is know that any alkyl groups are sent to a carboxylic acid. That's all you got to do. You're importing a lot of oxygens on something. Permanganate likes to eat away carbons. You can think of it as a carbon Pac-Man. So as you can see, but this is a good exam question. Permanganate does not, that's what I wanted to point out too. Permanganate it can't oxidize tertiary groups. So this is your exam question, something that I would like, or something that's maybe basically asked, given this molecule, what is the product? Well, you're going to know that not to touch the tertiary group. And this is a way, shortly we're going to talk about how the organic chemists like to protect things. I'm gonna show you a synthesis by a gentleman named Woodward that is an example of how the organic chemist uses chemical reactions to protect things. Okay, a lot of times in these classes we don't mention Woodward synthesis, but Woodward in the 1940s was a really hotshot chemist that needs to be mentioned. So I prepared a little slide, a PowerPoint about him as well. All right, you're gonna know Michael, Shana, you're gonna have it on the index card. You're gonna know if I add H2, palladium, carbon surface, you're gonna know I'm gonna get aniline, meaning I'm gonna take away the oxygens and add H's. Okay. Substituent effects. Okay. Some groups, Michael, Shana, Deepa, some groups are meta-directing and some groups are ortho-para-directing. And this is where also the organic chemist uses to synthesize molecules. All right. So NO2 is a meta-director, and then you have to memorize this at first until your understanding increases. So if I'm going to generate that same reaction, or I told you about that Japan, or my student at College of Staten Island, if I generate that nitroso, that electrophile, and I have a NO2 group on it, it's going to go meta. It's going to go 10 million times slower than the nitration of benzene. Okay. If I have a phenyl group, however, I get ortho and para products. I don't get the so there's a difference. So there's a difference between the NO2 group and the OH group. All right. So we have to memorize this. Here's what you're gonna make. I saw your index cards. They were awesome. He was the only person I saw with index cards. I do suggest you make index cards of this slide and know which groups are activating groups, strong OH, anything like OH, and know which are weak, and know which are deactivating groups. Know that the activating groups are ortho-para directors. The activating groups are ortho, and the deactivating groups, the weak ones are ortho-para directors, but the strong and moderate ones are meta directors. You have no choice to memorize this slide. This is a movie star, Jay-Z, Beyonce slide. Inductive effect. These are questions that always come up on exams. atoms are more electronegative than carbon, pull electron density out of the ring through the sigma bond. Okay, so if we have fluorine, obviously, what is it's E withdrawing. It's inductively, meaning fluorine has the highest electronegativity in the periodic table, electronegativity of 4.0. So it's going to pull electron density away from the ring. Okay, inductively, E withdrawing also is a acetyl group. S character plays a role. If the carbon, the more S character the carbon has, it's closer to electrons are more closer to the nucleus. Okay. Electrons can be donated into the ring or withdrawn from the ring by resonance. All right. So this is also a Beyonce slide. Really, all these slides should be in some form or fashion printed out. You can print out this whole PowerPoint or begin to make index cards of all 36, all 32 of these slides. All right. So something that's E-donating. Okay. The alcohol group tends to push electron density onto the ring by resonance. Make an index card of this. The acetyl group is E withdrawing. Okay. So it pulls electron density away from the ring. I'm going to repeat this concept again because it's very, very important. All right. OH groups push electron density into the ring. The acetyl group takes electron density out of the ring. It makes sense because oxygen on an E withdrawing has a double bond, and it could accommodate an electron. Index card this. All right. So why is it important to understand directing groups? So let's say I have this methyl group, and it's an ortho para director, and I'm going to do Friedel-Crafts with Br2, and I'm going to get a trihalogenation. But nothing's going to go in the meta position, meaning everything goes ortho para. Okay, and I get a trihalogenation. A catalyst is not needed. However, if I use that acetyl group, that's a meta director, and I'm going to get the Br in the meta position. All right. Then when I got to here in this series, Dr. Osborne then gets to he gets to 5 videos, all dealing with directing groups. That's how heavy a topic the directing groups are. Hint, hint, directing groups. So when we review, I'll try to look at the MIT exams to look for any problems like this. And I'll make a little more in-depth slides of these videos. This is a very, very important topic, and it's usually one whole chapter. Like there should be chapter 12 should be 12, 13, and 14. There's a lot of material on what we just talked about on the first 20 slides I just talked about. All right. So I'm going to, no further ado, I'm going to continue. All right. Why do substituents activate or deactivate an aromatic ring? So, of course, we go to the potential energy chart. You guys know how to do this by now. A lot of your questions, on the left side is energy, on the right side is reaction progress. So know that a more stable carbocation will give a lower energy. That's how we look at these charts. The more stable carbocation. All right, here's exactly what I had to know for organic 2 when I had Dr. Haberfield. I had an index card of this in 1988. If you met me in 1988, I was walking around with an index card of this. And these are meta directors, strong deactivating groups. Okay, so what happens is if I look at where that positive charge is actually sitting right next to that nitrogen. And I'm gonna move two electrons into it. And what I have is this vinyl group moving around. And it just makes, if I have two adjacent positive charges, it makes ortho and para pathways unfavored. I'm going to repeat. Two adjacent positive charges, because that positive charge is next to a nitrogen, it looks bad. Just looks bad. So it's just like a, so it's not going to do it. Meta directors, yes, the meta is preferred because it's going to avoid the two positive. Anything wants to avoid two positive charges. Opposites attract. So you can think if this is the opposite. Meta attack is done by is why? Because it's opposite attract rule. Okay. You can make up your own rule if you want. Okay. Ortho attack. This is kind of easier to. I remember in the understanding that ortho attack was more easier to comprehend. Okay. This fourth resonance structure is a major contributor to the hybrid. So remember in our conversations that there's that we see a unicorn, but there's no such thing as a unicorn. But we look for the unicorn, and we look for the combination of a rhinoceros and a horse. Well, that the resonance structure, this fourth one, all atoms have an octet. So that's the best resonance structure. That's the concept behind it. So hint, hint, this is a good exam question. Okay. And we will get an ortho attack. Good. Ortho power directors, weak activating groups. So Dr. Osborne went out of the way to make his own video just on ortho power directors, weak activating groups. So we need to know from that list which exactly ones are the weak ones. And he points out which resonance structures. The extra stability comes from the tertiary carbocation, makes ortho power pathways preferred. Okay. So then I had this slide just to know where to begin from. I'll play it for a minute so you can just hear his voice.
And go through the mechanism of electrophilic aromatic substitution and analyze all of the different resonance structures and see what factors we can find that help stabilize or destabilize the carbocation intermediate. So the first thing, the fact that this carbocation ends up in both the ortho and para pathways is why this weak activating group like a methyl will give you both ortho and para products.
Okay, so I put also in the PowerPoint, I put a link here and there so you could go back to them. Let me go back to the PowerPoint. So when you get here, you can hit the link, it'll bring you in that video series, and it plays one video after another. So again, the videos are about no longer than 10 minutes. However, there are 32 videos. So you have to plan out when are you going to watch these 300 minutes, these like 4 hours worth of videos. He made 4 hours worth of videos on chapter 12. So just bear in mind to try to take time out to do that. All right. Okay, we did that slide. Now, reactions of monosubstituted benzenes. So, Michael, say if you see this on the exam, you already made index cards. Today's the 28th, and you need to start, print out these slides and memorize these slides. And I made sure this PowerPoint is available in your portal, or you can watch the videos yourself. There are 4 hours worth of these videos. Okay, so meta directors, moderate deactivating groups. They're going to go for ortho attack. Ortho and para attack gives resonance structures that puts a carbocation next to a positive carbon, which is destabilizing. Reactions of monosubstituted benzenes. Okay, so you have to know now, okay, this was benzene. Now I have to know reactions of it being substituted, okay, with one group. But now I also have to know if it's also something if the benzene ring is di-substituted, which one is going to take over. All right. The position between metasubstituents is sterically hindered. So if I hinder it, then I can only send things ortho, which is how the organic chemist thinks. And so this is the type of thinking, if you meet a really experienced organic chemist, they'll tell you, well, Rob, I got to block this group so I can then hold that group or protect it. So we'll get more into that and how the organic chemist protects certain groups. So in the second example, I have one group that's activating orthopara and another group that's deactivating. So where's it going to go? Orthopara situations, those resonance structures are usually the way to go. So if I have a choice of something going ortho or para, pick it. All right? Okay, let's move down. All right, so here's where I got a little nervous for you. And that's the reason why I wanted to try to find the retrosynthetic software. I'll show you one of the two. I'll show you the one I had that was free. And there is one to download, but when you download them, when you download them, they kind of take over your computer. There is another type of retrosynthetic software that you need GitHub for. If you're a computer geek like myself and you have a GitHub account, you could download that as well. I'll have something or in lines, or also we saw that Gemini AI does give some form of retrosynthetic information that we could just make the molecules once we get the words for it. So we can use Gemini AI for the retrosynthesis problems, and I'll go over them. And I'll just find some examples so you can see how it's done. Okay, so but this is not a retrosynthesis. This is a synthesis. So we're going from some starting molecules forward. Bear in mind, you have to be able also to go backward. And that's kind of what normally not done to organic chemistry 2. Let's try to nail this down. All right. And this is what we did today. And this is what the class is all about. First, we need to we're going to put that acetyl group on the ring. It's meta directing. So when we do the nitration, it's going to go meta. And then we're going to do a Wolff-Kishner or Clemmensen reaction and flatten it out that ring. Sometimes all the slides I tried to capture them the best way I could. Shayna, sometimes they evaded me, but if you watch this video, this is what we would get. All right. So this is something you might be expected to do on the final exam. A problem like this. But you will be given the phenyl group and the end material. That's how well you would have to know these reactions. Again, don't leave anything blank. I'm gonna play the video for you a little bit.
We're now going to kick our synthesis up a degree And what we're going to do is add in the utility of the diazonium ion first to allow us to access additional substituents like FCN and OH, which we couldn't do before. But secondly, it's going to allow us to prepare substituted benzenes without forming undesired isomers. So there's a few tips to keep in mind. The first is one that we've talked about a couple of times, and that's that the bulky amide group of acetanilide can block out the ortho positions. So if you have this group, that's going to block out those ortho positions. So we can add that group on and take it off. The second thing has to do with having a para-amino group that can block that position, but it can subsequently be removed. So we'll see this when we do some example problems here in a bit.
Okay, so this is not one of the homework problems, all right? And it's not one of the problems I'm going to give her for your exam. So I'm going to go to those homework problems which she's going to have to base, but this is something you should know for the course. So I do want you to watch this video. All right. Again, you'll have a content folder of chapters 9, 10, 11, and 12. And I'm going to email her right now to ask her those two questions. Sorry, it's the main office again. Okay, sorry. I'm going to ask Dr. Gonzalez if the file is cumulative right now. Okay, so what I did just now, just to confirm, so it's in our I emailed, if you could see, I asked Dr. Gonzalez to make an announcement in the Blackboard, whether it's cumulative or based on 9 and 10. So just so for the record, all right? So let's wait to hear what she says since she's in the process of grading the exams. All right, guys? So let's see if she can make an announcement. All right, so let's see if she can make an announcement. All right, guys? So I just sent the email over. Wherever she is, she's grading the exams. And she's starting to. And then also she's, hold on, it's the main office again. Okay. So let's see what happens. So let's see if she'll make the an announcement on that. All right. So, and again, there's a certain number. I'm going to do the same thing. I'm going to give her the homework problems that I covered. So I'm going to cover those homework problems as well. All right. So now we're back at the PowerPoint, hopefully, which I want you to watch no matter what, because I want you to walk away with. And I want you to get to this video. All right. Thanks. All right. So far, so good. So far, so good. So I want you to have this type of understanding. Know that because this is what an organic chemist does. He knows how to synthesize molecules, and he knows how to block certain groups, and he has a certain strategy. And I'm working on downloading the retrosynthetic software for you. All right. This is the complete answer to the problem, and this is the last of the Josh Osborne videos. Now, I'm not going to give her these videos to base your exam on. I'm going to give her the homework problems. What we're going to do, we're going to go back. We're going to go to Rob's content folder. So let's go back to the content folder. And we're going to move up. Oh, before I get, okay, just one thing. This is a video of here's the PowerPoint that I just did. And here are the useful websites that I want you to review. And here's a video I want you to review. Okay, so let me do that. Okay. So here are the useful websites. I put it inside of a link that will come up. So if you go through this, Michael, Shane, I want you to go through this website. It's a really, this is where Dr. Osborne went to school, whatever. UC Davis is a website created by him. And these are, there's some examples. So I want you to go through this website. This is where the link is. I want you to hear the websites here. The Wolf-Kishner-Clemenson reduction. If something stands out for me what happens is while I'm traveling or while I'm reviewing the chapter, I'm saying, oh, okay, I want Michael to learn this, or I want Jennifer to make sure that she knows what this is. So if that ever happens and I put something in the content area, that's what I need you to know. So, or these are things that stood out for me. So I want you to know the Wolff-Kishner reaction. Here's a summary of it, that this acetyl group is a meta director, right? And I'm going to turn the meta director into an ortho power director. It converts a meta director to an ortho power director. So go through this site. You're not being asked mechanisms like at MIT, but you could go through them, okay? Okay, here is something that I saw that's never really, in organic chemistry classes, it's never really leaned on, but this gentleman made a video about what Woodward did.
British people, they wanted to plant this in their colonies, so they succeeded in planting this in India and Sri Lanka, and then Dutch people also succeeded the same.
So this is the synthesis of quinine. It's used to treat malaria. So obviously, it has a very important pharmaceutical, and hopefully, organic chemists try to make what plants make. They don't always succeed. But this was a nice video, and I liked it so much, I made a PowerPoint out of it. So I'll just show you briefly of what it looks like. You hold on. Okay, so if you can see the screen, this is a drug that treats malaria. And malaria is caused by parasites you get through infected mosquitoes. It can cause brain damage and organ failure. All right. So the organic chemist, Woodward being a hotshot organic chemist in the 1940s, tried to synthesize this anti-malarial drug. All right, there's a few of them. Antovorquinone, doxycycline, another antibiotic. All right, so this is what he did. During World War II, thousands of soldiers died to the scarcity of quinine. They didn't have enough of this this drug. So Woodward was used as a consultant, and this is his synthesis. As you can see, you're going to see some of the things that we've already. Here's the hydrogen, platinum, carbon, hydrogenation. You're going to see some things that we talked about. There's a hydrogen platinum reduction again. So this is what the class is all about. A lot of textbooks, they don't do him justice. I don't think they don't really take time out. So I just wanted to incorporate a little video. You could run the video. So if someone asks you if you had a class with Dr. Rob, he did mention woodward synthesis. All right. So let me now, what I'm going to do, Michael, Shana, what I'm going to do is now I'm going to get to the problems that we're going to base the exam on. And I'm just going to do that till 4, and I'm going to stop to ask you if you have any questions. All right? All right, so let's do this. So if you can see, here's the PowerPoint I made. It took me 3 days to make it. So I hope you like that PowerPoint. It's all the Josh Osborne videos. They're 4 hours worth of videos. Please watch them. All right. Here are the useful websites. If something sends me, I'll put the useful websites. Okay. And I'm going to come back to the exams from MIT shortly. Here's something on side chain oxidation. If something sends me, it's in the content area. Now, back last week, I wanted to see the size of chapter 12. So these are the problems I'm going to give her to base chapter 12 on. 12.33, 12.34, 12.37, 12.43. Here's what I'm suggesting that the exam be based on. All right, 12.33. Question is answered. Give reagents suitable for carrying out each of the following actions and write major organic products. So what you might be asked is a homework problem. You notice she can draw directly from homework problems. And you know the exam is not multiple choice. Nitration of nitrobenzene. So you would have to draw nitrobenzene and nitrate it. Bromination of toluene. So you'd have to draw toluene and then brominate it. Bromination of trifluoromethylbenzene. Sulfonation of anisole. So what I would suggest is begin to make your index cards and memorize this problem. Let's go back. Stop sharing. Share. Content area. Share. Hopefully I answered it. Okay, here's another. Michael, focus on this one. Jennifer, focus on this question. 12.34. Write the structure of the organic product in each of the following actions. If electrophilic aromatic substitution occurs, assume only mild substitution. Okay, so this question is not asking you a whole lot. It's not asking you to draw a mechanism. It's just asking you to draw a product. So the first one, you know you're going to generate this nitronium ion. The electrophile, bromine acetic acid. Go through all these problems. I did. All right, so here are the answers for them. I'll come back to it. All right, so you want to go through a problem like this. You can print it out. It's about 12 pages. I'm going to give her this problem to base the exam off of. $12.37. I'm giving Dr. Gonzalez this problem to base your exam on. Look out for this problem. 1, 2, 3, 4, 5 pentafluoro 6 nitrobenzene reacts readily with sodium methoxide and methanol at room temperature to yield 2 major products, each having the molecular formula C7H3F4NO3. Suggests reasonable structures. So this is a pretty difficult problem. You'd have to, you have what to write out. You just have to, it's a ring, and then you'd have to just draw out the structures. Please go through this problem. Michael, I'm shipping this problem over to Dr. Gonzalez. All right. One of the groups shown, which is most likely candidate for substitution of X. So you have to understand the rate of reactors for ortho, meta, and para positions. This problem is being shipped over to Dr. Gonzalez. And that's it. Those problems are these 12.33, 12.34, 12.37, and 12.43 are they're not easy problems. They're very lengthy. This is what I'm basing your understanding of chapter 12 over. Only this. I'm not sending the MIT problem exams over. I'm not sending anything else over. I'm sending these homework problems. What else am I sending over? Well, I'm going to make a content folder, and I'm going to go back to these problems. And at chapter 11, problems from chapter 11 on exam 3. These are the problems that are being shipped over to Dr. Gonzalez. 11.34, 11.36, 11.38, 11.39, 11.40, 11.41, 11.49, and 11.50. I'm going to repeat that. These are the problems that I'm shipping over to Dr. Gonzalez. They're here. 11.34, 11.36, 11.38, 39, 40, 41, 49, and 50. Write the structural formula for each. So you already saw on the MIT exam, they asked you the same thing, to write structural formulas. Please commit this to memory. 11.36, write structural formulas. That's the only thing I'm asking you to do. Bromine adds to the central ring in anthracene by 1,4 addition. Please understand 1,2 addition and 1,4 addition. Anthracene goes through Diels-Alder. Please understand the Diels-Alder reaction. Give the product from isopropyl benzene with these. Okay, these problems that, again, is not that you're not at MIT, so I'm not asking you to do that. It doesn't say, it just says to write the product. So you just have to know these reactions and then write the product. You don't have to write the mechanism. (11.49) both 1,2-dihydronaphthalene and 1,4-dihydronaphthalene may be selectively hydrogenated to 1,2,3,4 tetrahydronaphthalene. So notice so now I'm going to ask a question about heats of hydrogenation about it. Suggest an explanation for the observed SM1 reactivity of the following compounds. Then you're going to compare SM1 reactivity. So again, you might, looking at the substrates. So this is what's coming at you from chapter 11. Not everything here is coming from me from chapter 12. All right. Then I went to chapter 10. And these are the problems I'm sending over from chapter 10. From chapter 10, Michael, I'm sending over these problems: 10.25, 10.26, 10.29, 10.31, 10.32, 10.34, and 10.35. Writing some names. Write the structural formula of these compounds. Give the IUPAC name, which you're used to doing in these texts of these problems. 10.26, commit to memory. You know she likes these problems, so she likes the naming problems. Show to repair how you this is kind of a synthesis question, which I did I used that app, that Ortho Solver app, to do this one. Okay. Here's another kind of synthesis problem. Predict the major or organic product from 2,3-dimethyl 1,3-butadiene with each of the following. So then you have to know 1,2 addition and 1,4 addition. So here's what I'm asking you. Here's some things that you're going to be asked to know. 1,2 addition versus 1,4 addition. So I'll make this link available to one of the links. So you're going to have to know reactions of dienes. You're going to have to reaction of dienes 1,3 and 1,4. So I'll make a note of this. Let me take a picture of this with my iPad. So I'm going to take a picture of this one with my iPad and make this website available. Let's go through it a little bit. Kinetic versus thermodynamic control. This comes up a lot, okay? I'm even going to make my own index card of this. So I feel 30 years younger. See, I'm even making my flashcards of this. All right. So in today's post, we'll discuss 1,2 and 1,4 addition to dienes. Why do they go through it? How does temperature affect this addition? It wants to form the most stable carbocation. Okay. At low temperatures, the reaction is irreversible, and the lowest energy transition state will determine the major product. And that's what all those charts are about, those potential energy versus reaction coordinate product. This is kinetic control. At higher temperatures, the reaction is reversible, and the product distribution will favor the more stable product. Low temperatures, irreversible, kinetic control. High temperatures, reversible, thermodynamic control. Reaction of beauty. So this is really a nice website to go through. This is called 1,2 addition. So product 1 is essentially the same as we saw in the 1-butene example. H and Br are added across 2 consecutive double bonds. Note that since butadiene is symmetric, the same product is formed regardless of which double bond participates. So we call this 1,2 addition. One-4 addition. In contrast, product 2 shows the result of adding H and Br across 4 conjugated carbons. All 4 carbons participate in the reaction. A new CH single bond has formed on one end of the diene, C1, and CBr, formed at the other end at C4. So go through this. I like his website. this website too, because it goes through bonds formed and bond broken. All right, so I'm gonna make this a convenient. I'll make this one of recommended websites. So let's just backtrack a little bit of what I just spoke about, of what's good, what your exam is going to be based on. So right now, from chapter 10, what I isolated, Michael, Shayna, I isolated 10.5, 10.26, 10.29, 10.31, 10.32, 10.34, 10.35. And I'll go through them more. I did answer them though. I'll go through them more on Wednesday. They have been answered. So if you are pressed for time, you have to go through them, but I did this. The AI does generate the structures, so that's what. So it doesn't. It does help sometimes. It generates from the names. It does generate structures pretty well, and I could always go back and now that I have time, I could go into the homework problems and analyze them. You know, make them nicer, make them a little more attractive. 10.26 is on your exam. Give the names. You know that there's always this type of name. The first one is hepta 1,6 diene. B is 2,3,4 tetramethyl hexa 2,4 diene. C 1,3 trivinyl pentane. And on every exam there has been these problems. So she actually, when I say, hey, Dr. Gonzalez, I covered 10.26, she puts it on the exam. On every single exam, there has been naming. So you want to nail how to name, okay? Because those were some points they're going to come from. So you want to nail 10.26. On every single exam you've had, that's where it's come from. 10.31, I'm going to recommend this problem for your exam. Show how to prepare the following compounds from propene and any necessary organic or inorganic reagents. Now this, because I think that propene is not it's not a very large molecule and it's an alkene, you could use the aptitude. You could use the organic solver. Remember the organic solver that I had? So if you go into the content area, you can crunch 10.26 out with the Ortho solver. So you can use the Ortho solver for this, right? Because propene in question 10.31, I can simply draw it like this. Take these out. 1, 2, 3, 4. I'm going to make a double bond. And here's propene. All right. Now it asks you to it asks you to make a little bromide. So what can I do to do that? It got rid of my double bond. All right, so I can't use that. There you go. All right, so that's the answer. So this is the answer to, so you could use the Ortho solver. 10.31a asks you to make a little bromide. So I'll go through this problem. Over by one of my, I'll put this on the to-do list. So I'm using my iPad to do 10.31 with you on Wednesday. Okay, let's go back. Then from chapter 9, which I'll prepare for you, I'll prepare this review for you. So on your exam, Michael, I've asked Dr. Gonzalez to do these questions: 9.38, 9.39, and 9.42. So these are the questions that stood out to me from chapter 9, which I've answered, right? So problem, this is all one big problem too. I might have picked a few more from 9. I don't think so. Which describes what best happens in the first step of this mechanism. So this was, and I answered them as well. Oh, I did pick out a lot more. 9.26, 9.29, 9.38, and 9.39. So let me go through them. I picked out 9.26. So write the structure of the major organic problem isolated from 3-hexene. So you can use that same app that I have to do this. I could do that with you on Wednesday. I just want to get together what we're going to do on Wednesday. So this is problem 9.26, which I just used the Gemini AI to solve, but I could use, you know that hydrogen 1 mole of platinum is going to flatten out any double bonds. Lindlar platinum is going to flatten things out. And this is 3-hexene. So let me take a look at some things we could do. Hold on, I'm trying to find the solver. Got it. Okay, so let me go through using this is again question 9.26. Let me put 3-hexene up. Okay, so you can use this app or anything else you might use if you want to draw them out. What I like about this app though is I just drew the molecule 3-hexene for question 9.26. If I don't get to all these, I'll at least start with this one. And I can go into my add a reagent and just look for hydrogen. Just type here H2, and it comes right up. And this is the first reaction. And this is something beyond your exam. So I can take a picture of this one. And remember to go through it again. All right. This is easy to do with the Lindlar catalyst. I'm gonna change the reagent to Lindlar. And we get a double bond. So this is something you have to know for the exam. So I'm doing it now. So I might as well get a few images. And lithium and liquid ammonia. We don't have lithium, but we have sodium in liquid ammonia. Hydrogen chloride, 1 mole. I think in this question, for whatever reason, it should have left me with a double bond. This reaction shows the results of 2 equivalents added. Okay, so this one is 2 moles. So this one shows the reaction of 2 moles. If I just added 1 mole, I should have been left with a double bond. The concept behind this one is that you're left with This one also, it doesn't allow me to write one equivalent. It gives them, it always goes to two equivalents. Okay. All right. So the app is good for these type of questions. Chlorine, 1 mole. All right. It gives me chlorine. And I'm still left with my double bond. Now I'm gonna do it with excess. Wow, look at this, it's crazy. All right. Now I'm going to activate sulfuric acid and mercury sulfate. Here it is. I got the reagent. So this is not a bad problem. It's doable. Let's do the last one. The last one is ozone. Okay, so you should be able to, so 9.26, you should be able to handle it, okay? And that wasn't too bad. I'll try to get the retrosynthetic app. Hopefully that'll be ready by, by the next time we meet. So let me go to the textbook and let me just review from there, since I'll put that in your videotape as well. And then I'll open up the floor to any questions. I'll just spend like 15 minutes in each chapter, and then Wednesday I'll have a little more better understanding. Let's see if Dr. Gonzalez makes that announcement about the exams as well. So here's 15 minutes of chapter 9. So what we did was we looked at alkenes, and so now we just left the chemistry of the double bond, and now we went to the triple bond. So you just saw in one of the questions what we did. Sources of alkenes, naming, physical properties of alkenes, preparation of alkenes, reactions of alkenes, and we just looked at ozone analysis, we looked at some, and retrosynthesis. So that comes up in this chapter. And sources are not really brought about in anything. The naming, propine, 1-butadiene, 2-butadiene, that comes up on the exams. And the nature that we have this molecule that has a lot of dense electron charge. And we have this chart which compares some of the properties of ethane, ethylene, and acetylene. The acidity of acetylene, that comes up a lot. Knowing that, keep in mind this chart, that the pKa of acetylene is about 25 or 26 in most books. This comes up a lot. Okay, you saw it several times. You also saw it on the MIT exams. Okay, this comes up a lot, that the pKa of acetylene is 25, 26. The preparation of alkenes, how to prepare them. And then we have this monster sodium amide, which allows us to take this this hydrogen off the ring. And this is the first time that I began to see that now I have this molecule that I can add things on either side of it. So once I've made something like 1-hexene, I could also add something to the other side of it. I could add a methyl group on it. So I can have, so that's what's nice about it, is that I have this molecule that I can add things on both ends. So now I can start to build molecules. That's one thing I liked about alkenes when I started studying organic chemistry. So the chapter starts out slow, and then it gets to reactions of alkenes. So here's when you start to make your index cards. Wherever it says reactions, that's when the hydrogenation of alkenes, how you flatten out a triple bond to a double bond to a single bond. The metal ammonia, the Na, note that this reaction is carried out as cold. Sodium reacts with everything, so it has to be carried out at minus 80 degrees. The temperature reactions, addition of hydrogen halides to alkenes. So we just saw that in the sample problem. Hydration of them, knowing how to put an OL group, an alcohol group on them. Addition of halogen to alkenes. Okay, we just saw that in the homework problem. Ozone analysis of alkenes, knowing what happens when we split it up. Okay, so when we split up a terminal alkene, we get a carboxylic acid and a carbonic acid. Then the alkenes in synthesis. Okay, so we'll see more about this. And again, what stood out for me is that now I have this molecule I can manipulate and do a lot with. The triple bond you can do a lot with. Then it goes to the summary. Know these reactions. You want to make the index cards of these reactions. You want to make the index cards of this hydrogenation, metal ammonia. Then go through some problems. Addition of hydrogen halides, acid, anything in all the sections. And we go through the homework problems. So I'll do a little more in depth in the homework problems by next class, and then we should know whether the exam is cumulative. So this will give you 10 minutes of chapter 10. 10 minutes of chapter 10. Here we go back with the SM1 and SM2 reactions, except they're with allylic halides. Allylic free radical halogenation, allylic anions, classes of dienes, conjugated dienes. So I already showed you the website of the 1,4. I think I'm going to lean on that. Let me make sure I lean on the 1,4, 1,2, 1,4 edition, and Diels-Alder. That's what I want to lean on. Okay, here's the allele group. And know about SN1 rates and SN2 rates of the allele group. These type of relative SN2 rates and relative SN1 rates. And the mechanisms: allelic free radicals, allelic anions, and the classes of dienes. Okay, here's where things pick up on. So I want to focus on section 10.5 a lot. Come on. Okay, I'm making my flashcards as well. So I want to focus on section 10.5 and section 10.6. And the preparation of them. Addition of halogen. Okay, this is where we have to focus on, and then we have to go to the website on whether or not they're kinetically controlled or thermodynamically controlled. Halogenation to dienes. I want to focus on that. These are good problems to start with, and then we can get to the Diels-Alder reaction. Okay, here I want to digress for a second. Okay. So I want to PowerPoint this, and I'll see what Josh Osborne has to say about the Diels-Alder reaction. Because I don't think we spoke about this enough, but I knew I was going to review, and I knew I was ahead. So in the Diels-Alder reaction, a diene combines with a pi bond. Two sigma bonds are formed, and what's important about this reaction is that it's like the only reaction that we form like a sigma bond. Okay. In order for Diels-Alder reaction to occur, the diene must be conjugated and must be in the cis conformation. The Diels-Alder reaction is faster when there's electron withdrawing group on the pi bond. So now we know a little bit more about electron withdrawing groups. So let's take a look at it. The diene must be conjugated, so we must have this one conjugated diene. Okay. What we're looking at is 1,3 butadiene. And I went through what the Huckel orbitals were for this. So I want to go through Huckel again. The diene must be in the S-cis conformation. This I don't think I stressed enough. It must be in the S-cis conformation. Adding substituents to the diene or dienophile does not change the key bond-forming breaking pattern. Adding electron-donating groups to the diene increases the reaction rate. Adding electron-withdrawing groups to the dienophile. So this question I like a lot. There wasn't many homework questions on this, but let's go through it because this is you're gonna. If you didn't have this lab now, you probably won't get. You should get it. You should get a lab on Diels-Alder. I don't know why it didn't happen for you. The Diels-Alder reaction is awesome. When you do this reaction, it works, and it's really fun to do because you're actually doing some chemistry that actually works. And it's not like it's a large-scale reaction, but it's nice to do. Okay, so what is the Diels-Alder reaction? Or what is the basic pattern of it? This is the basic pattern of it. We form a new six-membered ring. The arrow pushing is easy to do. It's like this ABC move. So it's you have a clockwise flow or count. So it's a good way to learn arrow pushing. 4 things we need to know about Diels-Alder reaction. The diene must be conjugated. The diene must be in the cis conformation. The substituents do not change the pattern of the bonds formed or broken, but they do affect rate. So the diene must be conjugated. They must be in the S-cis conformation. So the molecule has to be like this. Okay, so this points out, right? So I'll go over this PowerPoint again. We'll go over this website. This is a good website. This is what I remember about Diels-Alder. So you're gonna put this methyl group on the dienophile. All right. Okay. Good. So I'm gonna go over this website on. I like this website. So I'm gonna go over this website on Wednesday. All right. And then I'll also go over this. I mean, I doubt that a Diels-Alder resonance solver has a resonance solver. Has a resonance solver. This has a chem. Is this might if the molecule is large enough, it might serve as some type of retrosynthetic analysis. All right. All right. So now let me see. Let me go back to the content window. Stop sharing. Okay, I just wanted to show that website. I also wanted to get. Thank you. Sorry, I want to get ready for Wednesday. Okay, I'm just going to give you like 10 minutes of each chapter, and then I'm just going to look at the MIT exams, which I'll show for you, so that you can see what the exams look like again, and then we'll. Okay, so right now we're reviewing chapter 10. So we already saw it talks about the allele cation, the allele radical, the allele anion, and then we talked about we're going to do Diels-Alder. We're going to spend a lot more time on Diels-Alder because that's important to walk away with in an organic chemistry class. And what else we're going to do? We're going to do Huckel theory. Now, Huckel theory, that's what I was surprised about this chapter, that it leaves the most important, it leaves the most important concepts for for last. While we're talking about Diels-Alder, this is the major part of the Diels-Alder. I want to talk about this just for about 5 minutes to 2 minutes. The molecular orbital analysis of the Diels-Alder, and this is why that's why people like it. Okay, it's like it works, and it's the theory behind it is like really easy to describe. When these two molecules come together, there have to be symmetry allowed, and that means that the highest occupied orbital of 1,3-butadiene, it has to coincide with the lowest unoccupied of the ethylene. So let's look at figure 1010. Okay, we'll do more of these all on Wednesday. The LUMO of ethylene and the HOMO of 1,3-butadiene have to have the proper symmetry to allow cycloaddition. The two molecules approach each other in parallel planes, and the electrons flow from the highest occupied molecular orbital of 1,3-butadiene to the lowest unoccupied molecular orbital of ethylene. Sigma bonds form when orbitals of the same symmetry, blue to blue and red to red, overlap. This is really cool. This is symmetry forbidden, all right? The highest occupied molecular orbital and the lowest unoccupied molecular orbital lack the proper symmetry to allow for concerted cycloaddition of two ethylene molecules. The orbital mismatch precludes sigma bond formation between the carbon of one and the carbon of the other. So when it forms this the cyclic butane molecule, it's symmetry forbidden. Here's a summary of the chapter. And I think, remember when I made that PowerPoint for you of Huckel theory. So I want to maybe just extend that a little more, because that was really, let me see if I can find it. That was really, I really wanted to draw that. Well, let me just stay focused, Rob. Stay focused. Go back to now to 11. So here's the chapter 10. Here's the chapter 11 problems. Benzene. Okay, again, this chapter 11, it's like really 3 chapters, and so is chapter 12. There's a whole lot of information, so I want to stress those Josh Osborne videos on this, and I want to stress what am I saying? Oh, the homework problems, because I'm drawing everything from the homework problems. All right, so let's do this. All right, benzene, the structure of benzene. She likes these questions when I give the nomenclature. We talked a little bit about benzene today. Okay. The dream, Kekulé had this dream of this molecule. Okay. The stability of benzene. The heat of hydrogenation chart. Bonding in benzene. This chart always comes out, meaning that the electrons fill the bonding orbitals and not the antibioticals. One of my flashcards. All right, so let's go. Okay, and today we spoke a lot about substituted derivatives of benzene. So on an exam, if you have to write bromobenzene, tert-butylbenzene, nitrobenzene, you know how to write what you know what these species are. O-xylene, M-xylene, and paraxylene are these dimethyl substituted. And then you know this list: benzo, carbonated by benzene, carboxylic acid. Okay, so you know this list. You know what TNT is: 2,4-trinitrotoluene. And you know this benzyl group. Polyaromatic hydrocarbons, you know these. This will come up, and I'll show you why the polyaromatic hydrocarbons come up from the MIT exams. Why something is most stable. Then there's the stories of carbon-60, Buckminster fullerene. It wouldn't be organic, and the chemistry of arenes. No, something like this. All these molecules have the same boiling point of benzene is not much different from similar hydrocarbons. and it talks about the intermolecular forces, the benzyl group, some resonance structures of the benzyl group, and it goes in the same spirit of chapter 10. Benzylic carbocation, the benzylic radical, and the benzylic anion. The carbocation, the radical, and the anion. Then it shows you the MO diagrams for them. So this is how the chapter is structured. Then what is the effective SM1 rates, of course, and then what is the effective SM2 rates. You had a problem like this on exam 2, which all of you did well. Okay. Free radical halogenation is always free radical halogenation questions. Benzylic anions, cations, and the neutral molecule. Then we go to alkyl benzenes, and the chapter talks about styrene. And the most important, I don't know why this section it's not exactly where it should be, but the Huckel chapter is really important. The Huckel section, which is 1018. Oh, the Frost circle. It's not really called a Frost circle in many textbooks. They do use Frost circles. I'm just going to briefly. Anti-bonding orbitals, non-bonding orbitals, and bonding orbitals. Huckel's rule. Okay, there's 4n+2 rule. I want to focus on this on Wednesday. Okay, and now just briefly, I'm going to go back to what I wanted to show you was the these are the slides from the MIT course that in a lot of these problems we look at stability. We look at the alkane stability through this reaction. Okay, so these are the slides from the MIT course. I thought they were interesting to look at. And you had a problem like this on the test. Looking at the stability of this molecule, this was the same exact problem you had on exam 2. This what I saw was height. This is the catalytic stability, and you see that benzene is predicted to be it's 36 kilocalories more stable than it is predicted because of its resonance. Okay. Benzene and benzene is not cyclohexatriene. Remember, benzene is a resonance hybrid. Okay, it's a unicorn. Okay. This is a really good exam question. It's asked all the time. Effect of aromatic stabilization on reactions of benzene, meaning in cyclohexene, we'll take the inventory, pi bond broken, the bromine bond is broken, and we form 2. We take the inventory. If it's benzene, no reaction occurs because it's so stable. So we have to instead use a substitution reaction to put bromines on the ring. And annulenes. Okay, so these come up in the Huckel questions, which MIT focuses on. So initially, all cyclic conjugated hydrocarbons were proposed to be aromatic. However, cyclobutadiene is so reactive that it dimerizes before it can be isolated. and cyclooctadiene adds Br2 readily. So they're not aromatic. If it was aromatic, it wouldn't do it. And this is what I think we needed to focus on a little more. Pi bonds, constructing MO diagrams. I don't, because I'm a physicist, I'm partial to it. P orbitals have two lobes, putting the P orbitals together. And remember, we formed that small PowerPoint I made. We form a bonding and an anti-bonding orbital. MO rules for benzene: 6 overlapping p orbitals. And again, so this picture comes up that the 6 electrons go into the bonding orbital. And here's the energy diagram. Here's the energy diagram, or you want to call it the Frost circle, that signifies the stability in benzene. This is the energy diagram for cyclobutadiene, and follows Hund's rule. 2 electrons are in separate orbitals because they have the same energy, most stable if filled with electron pairs such as benzene. If cyclobutadiene adopted a coplanar geometry, 2 of the molecular orbitals would each have a single unpaired electron. So cyclobutadiene is anti-aromatic. Okay, so this is what I like these slides, because if you can review these slides. I put it in the portal so you could see the difference between something being 4n+2 aromatic, and know that benzene is aromatic, and cyclobutadiene and cyclooctadiene are anti-aromatic. This talks about heterocyclic, so this is what comes up. A heterocyclic aromatic compound is something that has like nitrogen or sulfur in the ring. Okay, non-bonding pair of electrons in an sp orbital. So the pyrimidine ion is a weak base. And I think we spoke about these 3 molecules: the acidity of protonated pyrrole. I showed you the UC Davis website, and this is the these are aromatic cations and anions. These things are aromatic, and they follow the 4n +2 rule. Aromatic compounds like benzene undergo substitution instead of addition. So we need that that monster, that FBr3 monster. And here are some, that's why I wanted to show you some things behind the synthesis. Many benzene and naphthalene derivatives are useful drugs, and they have lots of benzene rings in them. Novocaine, albuterol, used for asthma. Okay, so I thought that was interesting. Okay, so lastly, before I open up the floor, come on. Okay, here's practice exam 3 from MIT. I'll show you it with solutions. So imagine, so this is exam 3. At MIT, there's 4 exams, and I think and then a final. So we spoke about the triple bond today. These are good questions, although they're from MIT. You should take a look at them. Know that the bulky base, the tert butyl alkoxide, is E2. Naming. Ozonolysis of an unknown compound gave formaldehyde, ethanol, and that's a carbonyl group and an aldehyde group. Okay. So it gave this monster something with I have to call it an aldehyde over that carbonyl group. What did it originate from? It originated from B. E, so the E and D, the diastereomer question still came up on the final or on this exam. And as you can see, it leaned, this is kind of like the exam that you just had. But your exam she didn't ask you to write any mechanisms. For 16 points, the following compounds indicate whether they react under SN1 or SN2 conditions. So you just had to know what SN1 and SN2 conditions were. So be in mind that might come back again. Then there were the synthesis problems. So you might want to just take a look at these two synthesis problems. They're not very in depth. See if you could do them. You could definitely do the second one. Then this one that asks you to, and there's no homework questions that ask you to provide a stepwise mechanism, but at MIT they ask you to do it, but you won't probably be asked to do it, but you can just take a look at it. So I just thought it would be interesting to look at, and that you could see what these exams look like. Then let's go here. Here's the final exam from MIT. So what's sticking out for me on this in order to design a synthesis, they give you the starting materials. I don't think I didn't give her any homework problems that had synthesis problems. You can just take a look at this, but as you can see on the final, by the time you get here, they're asking you all synthesis questions. You don't have to look at this because you're not going to get any questions from this exam. I just wanted you to see what it looked like. And you're just going to get the questions that which in that I'll make a folder of the homework problems which would be isolated, like what we spoke about in class, 12.43. These type I'm gonna 12.34. So know these questions. Just there's only 4 questions from chapter 12 that I wanted you to know. So you'll have that list. And lastly, I picked out the popular websites that I wanted you to see. You will have some type. I'll try to show you what a retrosynthetic software does. You can't use ChemDraw to do retrosynthetic analysis. I will show you a list of retrosynthetic software. This was the main site, which a few years ago, I had this on my computer, and it was free. And you used to this website, you was able to download the app, and you were able to do it. But they don't let you do it now. So what I'm going to do is I'm going to open up the floor and ask you any questions. Any questions? No questions? I'm waiting. Okay, so just to wrap up, I can't let you go just yet. It's too early. Okay. It's too early to let you go. So just wrap up, just so that we're waiting for Dr. Gonzalez to answer these questions. So I've emailed her. Yeah, she's grading them now. What I did was, it's important to be honest with people. So what I did was, that's the main office was texting me while I was here. After the exam, perfectly honest, I took your exams, I scanned them to myself and her, and then I graded them without an answer key. I used Gemini AI, but I learned from the first time that Gemini AI gives you lower grades than what you actually got. Like, it doesn't grade it properly because she has her own grading mechanism, and then it doesn't read the exams like very well. So I showed you an example deeper when you came to class of what it looked like. So then I saw there was no grade lower than, like, using my method, lower than 65. And it said that 5 people got 99s. Okay. So then I waited till this morning, sat, I said, of course I want you to do well because that's a measure of my performance as well. I think you guys should get some email to rate me. So you guys have to grade me too. So in this email, it says, Dr. Gonzalez, please, I asked her to make an announcement of whether the final is cumulative or based on chapters 9, 10, 11, and 12. If they're I'm just going to ship the homework problems over like I normally do and make a content folder. I'll go over exams 1 and 2. We'll go over everything. All right. I also put a sample letter of recommendation in case in case you don't get the grade you want and you need to take organic 2. I already asked her if I could teach organic 2, but see what she says, see what happens. If I could grab some of you for that class, that'd be great. And I think when you came in, when we met, I showed you my grading. I should pick the student, any random student. I picked their file. I showed you what this is what. Okay, she's graded the exams. All right, so she's finished grading them. So she's gonna post. Yeah, you got the same grades yeah, the AI pretty much did the same thing. You all passed.
Yes, he graded our work and it's posted on Blackboard.
Okay. Now ask her. Okay, now I'm gonna ask her. Don't tell her I'm doing this, all right? So now I'm gonna ask her. Okay, I'm just gonna say thank you. Thank you for the grades. Now I'm gonna ask her, is the final cumulative or based on problems from please let us know when you decide. Okay. Thanks for the score. Thanks for grading the exam. Okay. All right. So don't leave it all up to me either. You could email her. Okay. So she gave me the exams back.
But the exams has like 200 points, but C was supposed to be like
yeah,
130.
okay.
He has uploaded like 200 out of something like that.
Yeah, it's okay. Because you're in the summer, right? Just I don't know, and this is her way. I don't know why it has evolved this way, but she doesn't. Normally, your homeworks are worth 10%, and there's 3 exams. You drop the lowest grade.
But like our exam points are like 175 per exam.
Yeah. That's why I just said. That's why I washed my hands with it and just gave the exams to her to grade, and then I just based. I hope that you got the score you got based on my skill, based on my skill and what I'm advising you. You know what I'm saying? Mm-hmm. So that's all I had. All she left me with was my skill, because that's how the real world is. I don't mind, but if all of you got Fs, I would have looked bad. You know what I'm saying? Because I'm online. So I don't. So if I was in person, your grades would have been higher. You know, I'm sorry that this is. I'm normally a nice teacher, and we have activities, and we would have done things in class that I would have tried to increase your grades. Only thing I could do basically is just know that I just asked her again, was the final cumulative or not, and then we'll find out. And I'm going to send her, and then we're going to do the same thing for the final, and then we're going to find out when the final is.
After that, so, can you like make a folder like for like, final exam?
Of course, ma'am. Of course I will. You know I will, Deepa. You know I will. You know I will. And please, if you can, could you email her and ask her when the final? I don't want to keep harassing her. Email her and ask her when the final is. Mm-hmm. Or I don't know how. Whatever. I think you might be able to find out faster than me, because you can go to the registrar. You know what I'm saying? And then find out when the final exam is. So just ask her, just say, or ask her when is the final, because I need because that'll if the final is the 9th, that'd be awesome, because then I could, then we have all Wednesday, and we have the last day of classes is the 2nd, correct?
Mm-hmm.
So if the last day of classes is the 2nd, that means I can have an office hour on Saturday, right? So that means today we're going to meet Wednesday. So I'll prepare some type of review just like I did now. I'll talk about things that I know that you need to talk about, right? And then like I'll do some more of the problems, and I'll do focus on 9, 10, 11, and 12. I'll focus on the websites I discussed, the Deals Alder, Frito Crafts. I'll go over the Josh Os. This PowerPoint took me a long time to make, so I'll go over it again if you don't mind. This one. Hold on. Yeah, this PowerPoint took me it took me more than one day. So I'll go over this. I'll start again using this, and hopefully I'll have the retro synthetic software, and maybe I could just dissect some more of the videos. But my suggestion is that you watch. They're good videos. It's going to take you 4 hours to do it, because of each video there's 32 of them, and each video is approximately 10 minutes. So I would watch these videos. I would watch the 9, 10, 11, and 12 videos on Josh Osborne, and then I'll prepare maybe something more like this. I'll go over this again, because this is what the class is all about. Meaning, the movie star slides are this one: nitration of benzene, sulfonation, Frito Crafts acylation, the Clemenson reduction that stands out, MBS. This all stands out. This is a good exam question, knowing that an oxidizing agent won't affect the tertiary carbon. This you have no choice but to you have no choice but to put index cards on this. And if you didn't do well on this exam, you have a chance, because that's what I wanted, which you should. You have a really fighting chance, because today is the 28th. You have the 29th, 30th, 31st, 4 days, and then plus 9. So you have almost 2 weeks to learn this PowerPoint. And this is where I would make sure I would really stress this lecture. I would stress the last recording we have, and then I'm gonna do some things that I'm gonna do the 1-2-1-4 edition, the Huckel, and what things stand out for me in Organic Chem 1. So and then hopefully we'll also have this Saturday if you want. This slide also stood out for me in Organic 1. This is something I had to know. And this is not a file from MIT. It's not representative of what you're going to get. It's going to be based on those homework problems. So then I would then go back, and I'm waiting for her response. Is that it's going to be focused. I'm going to send her the homework problems like I've done before. You know what I mean? I'm going to send her this. And then for those of you who just got your grades and didn't get the grade that you wanted, and you're here and you can't drop, what I did was I am willing to write you a letter of recommendation, to take, or write an email of recommendation for you, that to I didn't have a way to give you extra credit for anything. So I can send an email off for you saying this person stayed for the whole class. So I'm just keeping this for a little while, so I didn't let you go that early. I'll do what I'm gonna do what I did before, and you'll have the materials folder like this of the homework problems, like you just like you just had, and then just go back and study those materials. I'll try to do that. I'll do that right now. All right. So maybe if I can, I'll do it. I could do it right now and show you in the next few minutes while we're here. So I'm going to go to here, and I'm going to go to share application, and I'm going to go to content. And then content is going to ask me to make a folder. I'm gonna make a content folder now. All right. So this is content folder for final. Okay. And what I'm going to do, it's supposed to ask you, okay, display it. You submit it, and then you go to the folder. This is the content folder. And then you build the content. And then I'm going to go item. No, it's supposed to ask you. It's supposed to ask you what do you want to put in it. Content folder, information. Okay, okay, I got it. Browse content collection. All right. Now, deeper, here's what I'm going to do. You go here, you go to the next items. It's beyond chapter 5. No, we finished. Okay. Huckel theory. Alkenes, female educator. Example of retrosynthesis. Let me go further. Then we go lesson 1, sample 10.25, 2.26, 10.1, 10.1, 10.32, 10.34, 10.35, 11.34, 11.36, 11. All right, the problem is I'm missing the problems from chapter 9. Six, 7, 8. Here you go. 9.26. Problems for chapter 11. Problems from chapter 10. Problems from chapter 10. I'm not going to put the MIT stuff, all right? The MIT stuff was just to show you, all right? Content folder for final exam. Let's see if it did it. No, it didn't. Content folder exam final. Again, let's try this again. Browse content collection. Huckel theory. Allylic bromination. Allylic bromination. Ten point 25, 10.25, 10.26, 10.31, 10.31, 10.32, 10.34. 10.5, 10.25. It's also being recorded so you can see the problems I'm picking. All right, now I need the problems from chapter 9. Okay, nothing from MIT. Let me see if it's submitted now. There are no selected. What do you mean there's no items selected? I just selected them. Oh, I don't understand why it's doing this. Hold on. These items are selected. 9 selected. Oh, I think I have to do it page at a time. It's saying there's 5 selected, 6 selected. I think I have to do it page at a time, Deepa. Hold on. All right. Submit these. All right, those have been submitted. Now submit, I gotta submit more. All right. Now I remember. Submit those. I may have submitted some of them twice, so let's just check. Submit. And let me make sure I got chapter 9. Okay, here's chapter 9. Okay, here's your folder. Can you guys see it? I'm out. All right. You guys are good?
Yes.
Okay. See you Wednesday, guys.